So again, we can ask about specific homework problems, or like general concepts, or like broad strategies, or what kind of whatever. So just holler at me, and we'd be happy to kind of work through whatever. Paul, we'll start with you.
It's a little confusing.
Sure. So number 11 from homework 1. Okay. All right, so the first thing that I'm going to want to do is find the values for A, C, H, and K. So before I can do that, I'm going to check to make sure my equation is in the proper form. Really what that means is checking to make sure the leading coefficient on x is 1. In this problem, I note that it is not already 1. So I'm going to start by factoring. So I'll factor the 2 off. When I factor a coefficient off like that, I'm dividing. So 2x divided by 2 is x. And then pi divided by 2 is just pi over 2. Now from here, I can see my values for A, C, H, and K. So far, so good? Yes? Okay. So the amplitude is the absolute value of A, so that's 1. The midline is y equals k, so that's y equals 1. The period is 2 pi times the absolute value of c, so 2 pi times 1/2 is just pi. And the frequency is the reciprocal of the period, so 1 over pi. Still doing good? I'm now going to fill out my transformation map. So that's Cx plus H, Ay plus K. I didn't write the 1 in front of the Y because you don't really need it. Then I'm going to go retrieve my key points for sine. I think these were in our notes. Oh, earlier back than that. No. So right here. So I'm just going to copy those in. That would be something that I would give to you. I wouldn't expect you to have these memorized. And now to get my new points, I'm going to take the x from my parent function and plug it in, and the y from my parent function and plug it in. I'm going to do that for each of these 5 points. So I get like pi over 2, 1, and so on. Let's see, that's going to be 3 pi over 4, and then 2. And then we have pi, and then 1, and 5 pi over 4, and 0, and then 3 pi over 2, and 1 again. Any questions on the arithmetic there? Just the reciprocal of the period. Sure. So then I'm just going to plot my points. So I know that each grid line is a half a pi because there's one blank grid line in between 0 and pi. Everybody's good with that? So I have pi over 2 and 1. So 3 pi over 4 must be in between a half and 1. So that would be there. And pi and 1. and there and there. So one period is that. And now I'm just going to extend my graph in both directions by just following the same spacing with the same point. So I go, let's see, max, midline, min, midline, max, midline, min, midline, max, midline. I'm just following the same order as the points previously. And we'll do the same thing in the other direction. So min, midline, max, midline. So there's what we got. Any questions about how I kind of extended things? Okay. Paul, you happy with what we did there?
Yeah, that.
Sure, no problem. Who is next? Blake.
Okay, so for numbers 25 through 20 or 25 and 26, it says identify the function rule based on the given graph. What do you mean by the function rule?
25 and 26.
It's in like the problem set.
The problem set. Did I mean to assign those yet? Oh yeah, sure. Okay, let me go grab that real quick. I'll take a look.
Like I don't really necessarily need them solved, but what do you mean by identify the function?
So I mean this.
So you're just asking for a
tangent equation.
Just a tangent equation.
Yep.
Okay. And so is a sinusoid not a tangent equation?
Correct. Sinusoid is a wave, so it's continuous the whole way through. A tangent one is not. Well, that was easy clarification.
Yeah. I was just like, well, what am I supposed to find here? Am I supposed to find like CAH and K?
Yeah.
Which,
So
I mean, yeah, you are.
Yes.
It's constructing an equation.
Yep. Yep. That's all. Sydney.
I have like a specific question. Could you go over how to go from a graph to sine? How to go from a graph to an equation?
For a sine or cosine problem?
For cosine.
Sure. So I'm just going to grab a problem from worksheet 3, and we'll just do one as an example. Does that sound okay? So let's do this problem number 4. So first thing I'm going to do is I'm going to locate the midline on my graph because I can just do that with my eyes. So to me, it looks like the midline is here. You guys agree with that? So that's at y equals -1. So that tells me that my k value is -1. Cool. Next thing I'm going to do is figure out the amplitude. So the amplitude is this distance from an extreme point back to the midline. So we're starting at -1 and going up to +2. That would be 3 units that we traveled. Okay. So the next thing I'm going to do is figure out the period. So the period goes from like an extreme point to another extreme point. Unfortunately, that's not like on a grid line, so maybe it's not easy to tell what that other hump is. So maybe instead I'm going to go from like this midline point to the next, or to the second midline point after. That might be a little easier to read because that's falling at a grid line. So that's pi units, right? We're starting at 0 and going to pi. because period is a horizontal distance, right? So we're looking at the x values as opposed to the y's. Still doing good? Okay. So I know that 1 period is 2 pi times c. So I can solve by dividing both sides by 2 pi. And we're always going to pick our c to be positive. So I know that c is going to be 1/2. Still doing good? The last thing I'm going to do now is figure out the value for h and use, and the sign for a. Since we know we're using cosine, I'm going to use the 0.01, which was a maximum. And then I'm going to choose another extreme point for my transform function. I could pick the minimum or the maximum, but I'd pick one of these two where they've given me the coordinates, so I can't possibly screw it up by reading the wrong point off the graph. Which one would you like to use? The maximum? Sure. So that's pi over 4 and 2. And you noted that that was a maximum. Because we're going max to max, what does that tell me about the value for a? It's positive. So in this case, that'll be positive 3. And the h should be? Well, because the x-coordinate for my parent function is a 0, the h is just going to be the x-coordinate for my transform function. So pi over 2. That's why we want to use 0, 1 or 0, 0 when possible. So then I just put it all together then. So I have 3 cosine of 2 times x minus pi over 2 minus 1. And that's one possible answer. There's more than one, obviously. But that one is correct. Does that feel okay?
So the difference between sine and cosine and the points that you use.
Right. So I prefer to use the point 0, 1 or 0, 0. Right? So if I'm using cosine, I'd like to use 0, 1, which means I have to choose an extreme point from my graph. Or if I'm using sine, I'd like to use the point 0, 0, which is a midline point, which means I have to take a midline point for my graph. Is that okay? Anise?
For the period, for tangent, you just use the vertical asymptotes.
You can, if you're reading, trying to figure out the period for a graph of tangent, yeah, you can use where the vertical asymptotes are and look at the distance between them. Absolutely. Paul?
Could you give a sign for this one?
Sure. So the only thing that's going to change here is possibly the sign on A and then the value for H. So from my parent function, we're going to use the point 0, 0, which is this midline point that goes minimum, midline, and then maximum. Now for my transform function, I have to also take a midline point. The one I'm going to use is this one here that's given to me because I don't want to screw up the point by reading the wrong coordinates or something silly. If I look at that point, left of it is a minimum, the right of it is the maximum, which is the same kind of midline point that I have in the parent function. Is that okay? So what does that tell me about the value for A? Because these are the same, the value for A needs to be positive, so 3 in this case. And the value for H in this case should be 0. That's correct. Again, since the x-coordinate of my parent function is 0, the x-coordinate for my transform function needs to be my h. So I would say this is y equals 3 sine of 2x minus 0 minus 1. And again, you could simplify that down, obviously, like the 0 doesn't really need to be there and all that jazz, but when I write these for you guys, I try to write them in relatively unsimplified form so it's clear as to where the numbers come from. Sydney.
So why is cosine 0, 1 and sine 0?
So if you go back and you look at these, the key points, 0, 0 is a point on sine, and cosine 0, 1 is a point on cosine. And we want to pick these points because we want the x coordinate to be 0, because that makes finding the h trivial. If we don't do that, then finding the h can be kind of a pain. But we can usually pick so that that's not a problem. Is that okay? I think on almost all the problems that we had to do, there was only like one where you, on the worksheet 2, where you had to use the bad one, right? Like where you had to make like a dumb choice and make it a kind of harder than it needed to be, I think. Blake.
Okay, so a bit more of a concept question.
Sure.
But so for sine A can be either positive or negative, whether or not it's like the graph goes down or up, I guess. There's probably a better term for that. That's what I'm calling it.
Well, let's just say what happens immediately after your midline point.
There you go. So what happens if you just get the point, like if you just say, oh, the midline is x and y, nothing else. Like you say, what, like constructing sinusoid off of that.
Mm-hmm.
What,
which type of midline point does it need to be?
Yeah.
Either one is fine.
Okay. Gotcha.
So like you're talking about a question like...
and it might not, there might not.
You're talking about something like number, like 5.
Like, yeah. Where you get a period, amplitude, and then the midpoint.
Right.
Like, how do you know
So if you use a positive or you use a negative, if you looked at the graph, it would meet all the criteria for this. It would have the correct amplitude, it would have the correct period, and it would go through that point at a midpoint.
Okay.
Right? So it's going to meet the criteria, whether the A was positive or negative. It wouldn't matter in this case. You'd still satisfy the criteria either way.
There you go. Thank you. That makes sense, yeah.
As opposed to, something like 8, where you're told that the extreme after the midpoint is a minimum.
Yeah.
Where now all of a sudden, like if you're doing sine and you're using that midpoint, then now the value for A is fixed because we know what is actually happening after that midpoint.
Yeah, okay. Perfect.
Cool?
Yeah, makes sense.
Okay. Jack. Jacob. I don't know why I called you Jack.
You remember 8?
Sure.
Or can you just do the part where you find A, C,
You started mumbling there at the end, and I
said,
didn't.
can you just do the part where you find A and C? Parts of the equation now?
Yeah, sure. So on 8, what we're given is just 2 points, and we're told what kind of points they are. I like to start by drawing a little bit of a picture. I think having a picture gives me a lot of intuition as to what to do. So that's what I'm going to do to start. So I have 2 and 15, and then like 8 and negative 5. So this is going from midline to extrema, and then I'm just going to kind of sketch in what the rest of one period would look like. Okay with that? So if I think about it, my midline has to be here, right? So it has to go through the point 215, so I know it's y equals 15. So I know that k is 15. Like for free, right? my amplitude is the distance between the midline and that minimum. So to go from 15 to -5 would mean moving 20 units, right? So there's my absolute value for A. Now the next thing I'm going to do is figure out my value for C. So what I want to know is from this midpoint to that extrema, how much of a period is that? Is it like a half? Is it a quarter? Is it a third? Is it a fifth? So we've drawn that much. And then back to midline, or midpoint is that. So there's one more. And then from midpoint to extrema, we have another one. And then from extrema back to midpoint. So I would say that's a fourth, the part that we have in yellow. You buy that? Just kind of using my eyes. So I know 1/4 of a period is going to be the horizontal distance. So it's going to be going from 2 to 8. So that's 6 units we covered. And I know a period is 2 pi times the absolute value of C. So I'm just going to solve that equation now for C. So I'll multiply both sides by 2 over pi. And we'll always pick C to be positive. Is that okay? All right, and let's just finish this off. We've done enough. There's not too much left to do, so let's just get a final answer. I know this was the part you cared about, was getting these first pieces, right? So this one, we know a midpoint and we know an extreme point. So we could use sine or cosine. It's not going to be really any more difficult to do one versus the other. Do you have a preference on which one we use? Okay. So we're going to pick cosine. When we use cosine, the point we're going to use from our parent function is 0, 1, which is a maximum. We have to pair that with another extreme point from our transform function. So that was 8, -5, which was a minimum. So because we're going from max to min, we know the A needs to be negative. And because our x-coordinate from the parent function is 0, the h is our x-coordinate from our transform function. And that's all we need. And there's an answer. Does that feel okay?
Yeah.
So the picture really kind of helps inform me what's going on, right? Like I can kind of turn it into the same problem as like worksheet 3, which were typically a little bit easier because you had more stuff to work with. And it was a little bit more visual. I'm a visual guy. I like to kind of draw the picture and see what's going on. It tends to back up my intuition as to what to do. So that's usually my first step on one of these problems, where you just give me 2 points as I want to draw a period. So and my graph looks, I know what it's going to look like. Just FYI, you can now check this, right? So like if I fire up my calculator and I plug in 2 for x, I better get 15 back. Right?
Are you in radians or degrees?
Yeah, I'm in the wrong mode. Boom. You guys see what I did there? So you can always check these too to make sure that you got the right thing. by plugging the point, you're making sure your point matches up. If you plug the x in, you get the right y back out.
So instead if you did the sine part, you could plug in the 8 and it was 5.
You can use either point, regardless of what you used. Like, they both should work. In fact, on a problem like this, it's probably worth, doing it again where you plug the 8 in. Because it's definitely possible that you get one to work and the other not. You could make that mistake. Usually it's a sign on A where that is the case. What's up, Jordan?
What's the, like, 1/4 thing? Like, I don't know. Like, I don't know how to ask.
So what I did is I was looking at my picture. I wanted to figure out how far was it between the 2 points that I got. Like, how much of a period was that? Right, so this is, like, if I called this guy A and this B, that's A and B, right? I want to know how much of a period is A to B.
Oh, okay.
So, like, I did a yellow. That goes from midline to an extreme. And then I went from extreme to midline. That's the green section. And then midline to extreme again, that's the blue section. And then extreme to midline again, that's the purple section. Each of those sections have to be the same horizontal distance because they're going from, like, mid to extreme. Like, the wave is symmetric like that, so I know that that's going to be, like, the same amount of stuff. Does that make sense?
Yeah.
You didn't convince me when you said yeah.
No.
So there's
No,
like,
it makes sense.
so the yellow is 1/4 of a period because there's 4 of these sections that are like the same distance, right? Or the same amount of the graph.
Or is it just because, like, A over B is 1/4? Or not, like 2 over 8?
No. It has nothing to do with the coordinates. It has to do with the picture. So, like, this amount of the graph is like 1/4 of one period, right?
And then you're flipping it. So is it always 1/4?
No.
No.
So I drew the picture, right? Here are the point A and point B are the 2 points I've been given, right?
Yeah.
And then I went and sketched in what the rest of a period would look like. So I finish going back to the midline, go up to the maximum, and go back to the midline. So it's one full period that I've drawn of my graph.
Okay.
Is that okay?
Yeah.
Because a period is going to look like, is going to look like that.
Yeah.
Right? I had only like that part of it.
Yeah.
So I sketched in the rest.
Okay.
So my question is, what percent of a period is that one part that I have that I haven't sketched in the rest? That's how I came up. That's how the 1/4 is, because I basically said, okay, to the midline to minimum is one section. Minimum back to midline is another section. Midline to max is another section. Max down to mid is another section, because those are all equal spaced apart.
Yeah.
Right? If I go look at the parent function, that's a half a unit, half a unit, half a unit, half a unit. Right? They're all the same distance apart. Or this is like max, midline, min, midline, max. They're all equally spaced. That's a property of these graphs. That's why the wave looks symmetric. Is that okay?
Yeah.
You know what I mean when I say symmetric?
Yes.
Oh, okay. So that's, since I have 4 of those sections, the yellow piece is 1/4 of a period.
Okay.
Is that?
Yeah.
So I'm just kind of using my eyes to do it. I'm not doing any calculation. It has nothing to do with the coordinates. It has to do with the fact that this is a midpoint and that's the next extreme up.
Okay.
So this is how I built that picture.
Okay, thank you.
Luke?
So if you have a minimum and a maximum, would you multiply the period by a half?
Right, so that would be like half a period, because now you're talking about like that piece, right? Which is 2 of those sections, so it's like half of a period. Yes, that's correct. Sydney.
Great. So, probably for this, but does it matter if, like, there's a difference between cosine and sine graphs? Or, like, if you're looking at, like, a type of graph, like, you can either or.
Right, you can answer these either way. Now, often one way is going to be easier than the other, but if you remember back, if we looked at our graphs of sine and cosine, let me just put them on the same axes here.
Whoa.
So the red is the sine graph and the blue is the cosine graph, right?
Wouldn't it be the other way around?
I'm sorry, yes. The red is the cosine graph, the blue is the sine graph.
Okay, so.
So the only difference between them is they're shifted horizontally just by a half a pi.
Okay, so when you look at it, like, if it's the peak is in the middle on the y-axis, then you should use cosine, but if it's not, you should use sine.
It really has more to... So if you're looking at a graph, if you're looking at the picture, it doesn't matter because you have both midline points and extreme points available to you. So yes, you could do that way, but it doesn't really no more difficult for you to pick the opposite one. It's if you're given one of these problems like we were just talking about where the entire graph isn't available to you and you only have certain points to work with, that's where making the choice is really more critical. But basically what it comes down to, if you're given midpoints, use sine. Or if you want to use a midpoint, use sine. Or if you have an extreme point, use cosine.
So if you have both, it doesn't matter?
So in this case where you have both, it doesn't matter.
Okay.
It's going to be equally easy. Either way.
Okay.
Amanda.
Well, we need to memorize, like, the key points for the cosine and sine.
No. So for graphing, the key points, no. I would provide those to you. Aria.
So, except for questions that are like passing key points, like when it comes to the ones that were like on worksheet 2, you basically just ignore the live limit when it comes to like actually writing the function. Like the K is like the midpoint, right? So you just ignore that.
The K is from the midline.
Yeah, but then so you just ignore like for number 9 on worksheet 2, like you ignore like the negative 20 and 18.
I would not need those to find K necessarily. I could find K just kind of looking at the picture. Or I could use those to find K directly without having to do the mapping. But you could certainly use the mapping to find K. It's not wrong to do that. That will work also. That's what you wanted?
Yeah.
Okay. So again, there's often lots of ways to skin one of these problems. There's not like one set way that you have to do it. There's like lots of ways you could do it. Blake, did you have something else?
Yeah, this is once again a more like kind of broad question.
Sure.
But if you have a period, why is a frequency important? And what is it like really about?
So frequency is describing to you how many periods you have per one standard unit.
Oh, okay.
So like if you're doing anything engineering related, like how many times does this thing spin around is per one unit of time is often going to be interesting to you. That's describing a frequency.
Got it.
Now when it comes to like generating a graph, it's not very helpful to us. But like in a practical engineering type setting, a frequency might be something that has a lot of meaning.
Got it. Okay, that makes sense. Yeah, thank you.
No problem.
I really understood why it was there.
Yeah. Because oftentimes you're talking about something that's spinning over time. So a frequency is basically how many times it's going to spin around in a second or a minute or whatever.
Yeah, I get what you're saying.
So, and that's often very interesting to you as an engineer. That's
important.
yeah. Who's next? Happy to do some more. If people have some more stuff they want to talk about, or if you just need a minute to process and come up with something, that's okay too. Yes, Tegan.
This is kind of just a common thing, but it's only I can do
Sure.
when you're seeing if a sign is positive or negative, it's negative if the midpoint is going down. I guess that's kind of hard to explain.
No, I understand what you're saying.
Yeah.
So what you're saying is if you're looking at this point,
Right, that'd be positive.
that would be positive A because it's going up. But if you're looking at this point, that'd be a negative A because it's heading down.
Correct. Okay.
Yeah, that's an appropriate way to think about it also, for sure. That's what you're getting at though, right?
Yeah.
Yeah. And in fact, let's just take that out of there and just put like a midline in and get rid of the y-axis so it doesn't look like we're just talking about sine, the parent function. Now it's just like some kooky thing, right? Jordan.
I'm confused here. Can you go back to the one where I was asking about the 1/4?
Sure.
I don't know, what's what's the equal 6, I don't know.
So where did the 6 come from?
Yeah.
So the period is the horizontal distance, right? So one of our points started at 2, and then we went all the way to 8. So we traveled 6 units
Oh,
horizontally, right?
can you do something else where the period isn't 1/4?
Sure. We can do 9. You want to do 9?
Sure.
Okay. All right, so we have 10, negative 20, and then we have 46, 18. And we're told that 46, 18 is actually the second maximum afterwards. So this is going to come up for one maximum, go down, and there's my second maximum. Does that feel okay there?
Yeah.
That matches what the picture is describing, right? I have a minimum, and then the second maximum after that is my other point.
Yeah.
So I'm going to go and count and see how many periods or how much of a period I have here. So if I go min to min, that's 1 period right there. You agree with that?
Yeah.
Okay. And if I go min back to max, that's another half of a period, right? So what I have here is 1.5 periods. And how did I get to that? I went from 10 to 46. So 36 units.
Alright.
And then I can put in the 2 pi absolute value C and solve for C.
Okay.
Is that okay?
Yeah.
So what's C going to be there? 12 over pi again? Yeah. Luke.
So your multiplied it by 2 over 3.
So if you look, I said there that one period is 2/3 times 36, which would be the same thing as if I multiplied both sides by the reciprocal. Right? This is 3 over 2. 1.5 is 3 over 2. If I multiplied both sides by 3 over 2, I'd have this, right? Or by the reciprocal of 3 over 2, I'd have that. If I divide both sides by 1.5, the reciprocal of 1.5 is 2/3. So it's the same equation, it just arranged so the period was by itself already. That's all. I promise you it's an equivalent expression. You don't need to do it that way. But I promise it's the equivalent thing. Right? If I have like 3 over 2x is equal to 36, that's the same thing as saying x is 2/3 of 36, right?
Okay, yeah, gotcha.
That's all we're saying.
Yeah, all right.
That's all. Rule aside. Anybody else? Okay. You guys all know what's coming, right? You ready?
No.
Yes. Yes.
Ish.
No.
Here, if you ever are unconfident in your ability, just think about your FaceTime call with Hugo.
I feel like Allie is in this community. I don't know.
That is accurate.
It came from the depths of hell. All I have to say. Oh, whoa. Mitochondria might be the powerhouse in the cell, but the collagen is the powerhouse outside the cell.
This part is serious on the math. I show a picture of everyone.
So you're telling me that Mr. Clues about how fun
I
surprise.
heard that as a lesson.
That's not a bad
He was gonna get a math spider.
A math spider.
Can I have a second?
Thank you.
24-hour notes. Give me a second to pass it out.
I didn't do that in school. What am I so supposed Yeah, no idea.
It's all good. I always just write it down like in my notebook.
It's been a couple of days. I got to it. I'm like, I should probably say something that no.
Oh, did Miss Garcia give you your calculator?
Thank
Sorry.
I didn't remember food school. I don't sleep enough anymore. You?
Yeah.
Oh,
Sounds good.
I'm so sorry.
So,
Daddy! No, 2-year-olds are so like kids.
Can't you know, Maddie?
Kids in general.
so the last 2 years have been kind of a blur. And my memory's gone downhill considerably, especially when it's like somebody passingly telling you something. You know what I mean? Like if you've pulled all-nighters all week and somebody tells you something, you just